morning, friends. Let's talk about genetic algorithm today. And after a long time, I'm making this video because I was busy in some kind of projects and all. And let's see what is genetic algorithm, what are the implementation of genetic algorithm in this modern computation era and modern era of machine learning and artificial intelligence. Actually, genetic algorithm is thing like something where a program adapts something automatically from the previous results and all. So let's see what is it and how it works. So mainly genetic algorithm is just like a what can you say? It's just a program which adapts thing from the previous data and previous results. So if you're going to define what is genetic algorithm, it's just a the adaptive heuristic search algorithm that belongs to the larger part of a evolutionary algorithm. And genetic algorithms are like uh, based on ideas and selections which are the best and which has the which are it just you can say it just belongs to something like which has the best result or which is the best match result. So it is like these are the intelligent exploitation of random search provided with the historical data to direct the search into a region for better performance and solution space. uh, might we may know about brute force in something ethical hacking or something like that. There is a term brute force where a hacker tries to break the password of a user ID. If a hacker knows the user ID of an account and he tries to break the password with multiple tries with a dictionary. So what it does actually, like it tries each and every word from the dictionary as a password, and if the password matches, then it gives access to the account. Sorry, it gives access to the it gives the account access to the hacker. So it is just something similar like that. So let's see. Before going to more deep in the genetic algorithm, let's think about something. If I'm going to give you for a five alphabet combination, how what is the possibility that you can make some words from that five alphabets by scrambling it randomly? So something like that. There is a problem. There is an iconic problem which led to the concept of genetic algorithm. It is the Shakespeare and monkey problem. What is the Shakespeare and monkey problem? It is like if a monkey have a typewriter and it started typing randomly and with scramble alphabets, how long it will take? How long it will take to type or complete Shakespeare's work? So that's the actual thing that generate sorry that generated the idea of this algorithm. So to simplify this problem, let's see what are the probabilities of this problem. So let's imagine a keyboard with okay, Shakespeare's work is too big for this problem. So let's take a simple word that is to be or not to be. Okay, that's a simple phrase, to be or not to be. So we have to find the combinations for to be or not to be. So how long it will take? It is like in a typewriter there are simply because the phrase is in a small alphabet. So it will, let's take the small alphabet keyboard, which is and it also includes spaces. So including spaces, the whole alphabet keyboard is around 20 is exactly 27 keys. So if you take the only T alphabet T, so it is likely the chances are 1 by 27 that if a monkey presses all the 27 keyboards 27 keys in of a keyboard randomly, then it will chances is only 1 by 27 that it will occur T. So something like that. If we are going to write the word to, then what will happen? The monkey has to press all other keys from the keyboard, like A to Z, and the space is included, and the O letter will occur once. So the probability is 1 by 27 into 1 by 27. So likelihood the typing the whole phrase, it is like 1 by 27 into 18 to the power 18, because of to be or not to be is an 80 character long phrase, so it will take around 1 by 27 to the power 18. So it is like similar to 1 in 15, this number even I can I can't count what is it. It will take me too much time. So it is like let's see how long it will take. How long it will take if we are going to get if we are going to brute force it with the dictionary, like as I said in the ethical hacking part. If you are going to brute force it with the dictionary, it will take around similar to this amount of years. And don't forget that earth is all actually this years old, estimated, sorry, not actually, estimated. So this way it can't be, it is not possible to break any kind of to guess any word or guess any phrase with that. So why why and how the genetic algorithm idea has been evolved? It is actually an idea evolved from Darwinism, the Charles Darwin's theory of evolution. And Charles Darwin, it is like uh, he published a theory of natural selection which included 5 main points. First one is the initial population, second one is the fitness function, and third one is the selection, fourth one is the crossover, and fifth is the mutation. So in initial population, it is just like how the all of the Darwinism theory is about how the genes of animal and all the living organisms got fused and get reproduced the offsprings. So it is just like the our algorithm is just like that. It gets the data from the previous results and it reproduce the next result as per these 5 rules. So let's see how it works. So let's think about first initial population. It is just like a set of genes, and here, like it is written here, the process begins with a set of individuals which is called as population. Each individual is a solution to the problem you want to solve, and an individual is characterized by a set of parameters known as genes. Like humans have 23 pairs of genes and all. So let's think about if we have if we have to take gene in genetics and computer science, we can use alphabets, but in algorithm we let's just use binaries 0 and 1. So this is, you can say, this is a total population, and these are chromosomes, and this is a gene. Okay, this the single total one string of chromosome has 6 numbers of gene I have represented here, and this is the entire population. So genetic algorithm, what it does in this case, it takes all the results and compares them to create a next create the next result, so that it can match the actual what we are looking for. So in this is the initial population, and let's talk about fitness function. The fitness function determines how fit an individual is. Actually, how fit an individual is. It is it can relate to human reproduction system, any kind of reproduction system you want, but in computer science or in genetic algorithm, machine learning, all these things, fitness function is like if you are going to take a word example here, like I have taken this example, the computer, and these are the words I am typing randomly, like monitor, computing, motor, letter, conducer, lecturer, putter, banana, and crumpet. So we can see what are the fitness score here. What is fitness score? What are the alphabets or what are the characters matched to the main word which we want actually as the output. So it is like here in as in computer, here you can see monitor, so O I T O R, sorry, O and T and R. So only there are three matches, so fitness score is 3, and here in computing it is 6, and motor it is 3, letter here is 4, conducer it is 6, lecturer it is 7, putter here is 6 because 6 of the letters matches to the word computer, and banana there is 0. So crumpet it is 7, and the if you're gonna compile that which are the sorry if you're gonna collect which are the fittest words, so fittest words are according to this course, these are computing, conducer, lecturer, putter, and crumpet. So this is a fitness function. as a whole, what fitness function actually works. Fitness function was like choose the words which matches the word, matches the most, which to the word we desire. So something like that. Okay. So selection. So selection is like to select the fittest words, and to try to match them to get the word. To define it, let's see. The idea of selection phases is to select the fittest individuals and let them pass their genes to next generation. Two pairs of individual parent are select based on their fitness scores, as like I selected some of the fittest words in the previous example here. And individuals with high fitness have more chances to be selected for reproduction, as the uh, highest fitness score, the words does have highest fitness score, can get through the next process to uh, get the word more typically. So selection is like a process, but selection is not possible in each and every cases, because uh, this is just a 8 letter word, and I have it is just an 8 letter word, and so and it is fixed and it is artificial. So I have created these things, and I just got the fitness score so easily. But what actually in real time cases, how it works, it takes thousands and millions of attempts to get near to the score. So selection process is like getting the fittest to get the word, and to compare the fittest and get the word, what is the word actually. It is bit it is too fast than the actual dictionary thing. So crossover, what is crossover actually? Let's think about crossover. Okay, first think about the word. What is the word? Computer. Compute, and compute and lecturer. We can cross over compute and lecturer to get computer, right? So some like that. If we have two genes, there is a1 string and there is a a2 string. A1 string contains a1 chromosome and a2 chromosome. So a1 chromosome contains six genes with zeros, and a2 chromosome contains six genes with ones. So it can be crossover like zero. First three zeros comes to the a2 string, and first three ones go to a1 string, and the result will be, the offspring result will be triple one triple zero and triple one triple one triple zero and triple zero triple one. So this is like crossover. It gets to it takes the fittest and just cross it over. Yeah, but the main thing to notice here is it is just artificial, and I have made an example and I know the word exactly. So it is like we can get the result too easily than the other comparisons. So what is mutation? Mutation is like we know the genetic mutation thing, like right from the X-Men movies and all. Genetic mutation is like the our current genetic material, our chromosomes and our genes get mutated by any reason, and or any get mutated, you can say. So by any artificial factor or any outer factor. So it is like our string of DNA or our string of output, or our output can also be mutated to check if the fitness score, if rises, if increases or decreases. So by this mean you can find out the actual word, what we were looking for. So let's come back to the Shakespeare and the monkey problem. One way to solve this is with an algorithm that starts to generate phrases randomly. Okay, so here you can see we are randomly generating phrases here, and here you can see total generations, how much we are generated, and fitness, we are looking for the fitness score. Okay, and we can see how much we have total populated, and mutation rate, how percentage we are mutating. So this is just a GIF from a code, and in the next video I will show you how it works with Python, and with various programming languages like in Python, C++, Java, and Rust, or in JavaScript. I will show you how it works. But it is like we can say by this process we can guess the actual word we are looking for easily than searching for the whole dictionary. It is like searching for a whole dictionary is like you have to type all the alphabets from A to Z, and we have to type it randomly for each and every letter. It will take, as I said, this the it will take too much time to handle to get guess the actual word. And even we don't know what is the what if we, and we will not know the how much we are how much we are accurate, or how much we are nearer to the actual word. So here in this case we have a fitness score which is very important to know how much we are nearer to the actual result. So you can say how much this mutation is working, how this is just a mutation algorithm which is working perfectly to guess to be or not to be. So this is all about genetic algorithm, the basic concept of genetic algorithm. In summary, we can say genetic algorithm is just a algorithm to guess a word or phrase or something like that um, through algorithms. And it follows the Darwinism theory of evolutions. And it is just fun to guess something like what we are to get a password, or to get a word we are looking for, or to generate random words. It's it is actually good. And uh, we can say it is better for encryption and decryption also. So what are the applications of genetic algorithm? That's actually good question, good and fair question. In the case of what do you say, machine learning, genetic algorithm is a uh, great advantages to guess, and to get adaptive. Let me show you something. Yeah, yeah, okay. uh, 2D car game. Yeah, here this is a car game with HTML5 and genetic algorithm. Just it just drops a bunch of cars, and get the results get generated, that which shape of shapes car is traveling faster and scoring much longer distance. So according to these results, the cars get generated by one, and the uh, structure of the car get modified. So something like that. It is just a part of machine learning, and it uses genetic algorithm which learns from the previous results. Something so as genetic algorithm is a what can you say? Genetic algorithm is a key feature. We can say key feature to machine learning. So it's the best thing to know and best thing to adapt in this modern computation era and era of machine learning. So that's for all today. And in the next video we'll see how it works with Python, C++, Java and JavaScript. I will show you the result in all of the five languages. So sayonara till that. And if you like this video, please like and comment, and don't forget to subscribe and press the bell icon. Thank you.